Hello everyone, myself Dr. Santamay Kundu. I welcome you all to this lecture of soft computing techniques. This is the first lecture in module 3. So, we have covered module 1 and module 2. In module 3, we will try to understand fuzzy inference, fuzzy rule based system. In module 2, we have discussed some fuzzy rules, that is fuzzy if then rules. So here first to try to understand the classical if then rules. So rule 1 is that if the speed is greater than 100 km per hour, then stopping distance is 20 meters. So it is value is given in, so that is a Cripps thing. Similarly, if another rule that if speed is less than 40 km per hour, then stopping distance is 60 meter. Now fuzzy if then rules, these sets will be given in terms of fuzzy. So if speed is high, so this is a fuzzy set if the speed is high, then stopping distance is long. So this first and long, these you know, these are not a classical set, these are the fuzzy sets. Similarly, this rule 2 can be written as if speed is low, then stopping distance is short. So fuzzy rules are related to fuzzy sets. So if the you know that rules, if A imply B, so this A set is known as antecedent. So if the antecedent is true to some degree of membership, then the consequent, that is B, is also true to that same degree. So try to understand this concept. So it says like that if A is these things and B is these things, suppose the value of this is A, this is B, so the membership value of this, suppose it is 0.3, so that membership value here also the 0.3, same thing. So this will be the output. Suppose if it's x, then mu x is 0.3, so here the mu y, that also should be the 0.3, so that is same degree. So that is y value is also 0.3. This mu value also 0.3. So the rule says that if the antecedent is true to some degree of membership is 0.3, then the consequent, that is B, is also true to that same degree. So this will be the 0.3. So here if input, you can check if input is x such that mu x is 0.3. So mu y, if mu y 0.3, then output is y. Output y such that mu y equal to 0.3. So now try to understand that a fuzzy rule can have multiple antecedent. For example, if project duration is long and project staffing is large and project fund is inadequate, then risk is high. So there these all are antecedent. So another example is that if service is excellent or food is delicious, if service is excellent and food is delicious, then tip is generous. So that is more than one antecedent. The consequent of a fuzzy rule can also include parts. For example, if temperature is hot, then hot water is reduced and cold water increase. So here consequent is more than one part. So in the module 2 we have studied this thing. Suppose A represent this fuzzy set, B represent this fuzzy set. So if A represents the fuzzy set which is 0.2 by T1 plus 0.5 by T2 plus 1 by T3, B represents by the fuzzy set which is 0.3 by P1, 0.59 by P2, and if X is A, then Y is B, can be used as the relation which is R. The relation A imply B can be written as A cross B. So here the row you will get A which is T1, T2, T3. In column you will get the P1 and P2. Then you need to write the minimum value of that. So minimum value of 0.2 and 0.3, that is 0.2. Here also 0.2. Here 0.5 and 0.3, that is 0.3. Here it is 0.5. Here it is 0.3 at 0.9. So that part we have discussed in module 2. So revise once again. Now example 2 is that if temperature is high, then humidity is fairly high. So that is temperature is represent T, fuzzy set 20, 0.1, 30, 0.5, 40, 0.9. That humidity H represented by the fuzzy set 20, 0.2, 50, 0.6, 70, 0.7, 90, 1. So where T is the fuzzy set for temperature and H represents fuzzy set for humidity. So find the membership rule by using Mamdani implication rule that is, we have studied in unit module 2. So here you need to write the A cross B which is the minimum of these two. So 0.1 and 0.2 minimum 0.1. Similarly 0.1 0.6 minimum 0.1, 0.1 0.7 minimum 0.1, 0.1 0 and 1 minimum is 0.1. Similarly 0.5, 0.2, 0 minimum 0.2, 0.5 and 0.6 minimum 0.5, then 0.5 and 0.7 minimum 0.5, then 0.5 and 1 minimum is 0.5, 0.9 with that 0.2, then 0.6, then 0.7, then 0.9. So this is the another example. Now another example is given that this is the height, it is given as height. So here height is 170, so the mu 0.2 is something like 175, then this is 180, so the height is something like 0.6, 180, then 195 value is something is 1, so that is represented by height. Now this is represented fuzzy set represents weight, but here input is 175, so take the membership value that is 0.2. So here also you take the line 0.2, here it cut 8, so here output is 80. Similarly the height input is 180, so here take the membership value 0.6, so it will be the same degree of membership, that is 0.6 to take here, so we get the output that is 90. So for 180 height in centimeter, weight is 90 kg. Then again now 195 something is here, you take the value 1, so the membership value 1 here, so now if you drop here you will get it something like 102. So if input is 195, output is 10.2, so that is the same degree of membership. You can write it is the input and output at the same degree of membership. I am writing here same degree. So in this way you can find the output from the fuzzy rules. Now there are two types of fuzzy rules, fuzzy if then rules. If x is a, then y is b. So a coupled with b, that is a and b. So a and b represent as a cross b. So this part is a, this part is b. So this is basically the represent A cross B, you can write it A coupled with B. So now A entails B, not A or B. So A is given, so that is not A or B. So take the union of these two. So this is B and this is not A. So take the union. Now fuzzy inference. The basic rule of inference is modus ponens. We can infer the truth of B from the truth of A and the implication A imply B. Would like to find the resulting fuzzy set B. So suppose if A, the rule is that the fuzzy set A represents the apple is red, fuzzy set B represents apple is ripe. It is true that the apple is red, so it is also true that the apple is ripe. So we'll do the same thing with some example. So this is basically, you can say, the rule which is given. The rule is that this is rule: if x is p, then y is q. Fact is that, or given fact is that x is p. X is p. So conclusion, y is q. So you can check this modus ponens. You can say that modus ponens is that classical modus ponens, this part. Now generalized modus ponens. Now generalized modus ponens. So fact rule is that, for case of generalized modus ponens, rule is that if x is a, if x is a, then y is b. Fact is that x is a dash, I mean some closer to a. It is represent the fuzzy set, some closer to a. So conclusion will be y is that closer to b dash. So conclusion, y is b dash, that closer to b dash. So that is given here. If x is given, or fact x is closer to a. So if x is a, then y is b. So conclusion, y is that closer to b. So here a dash a dash b, all are the fuzzy sets of x, and this is also the some fuzzy sets and y respectively. So let a and b are fuzzy sets of x, x dash, y respectively. So assume the relation A imply B here is expressed as a fuzzy relation on x cross y. Then mu, the value of mu B bar y, output value, is the max min composition. So that is A, this is given, A dash, this relation R. So there is A dash composed A imply B. So where A imply B, if x is A, then y is B, with the implication of J, the max min rule. So it can be written as this A imply B, that can be written as R, that is simply A cross B. You know that union A complement cross Y, where every membership value of Y is 1. You have studied these things in module 2. So single rule, so single rule with multiple antecedent. The rule is that if x is a and y is b, then z is c. It is given, or fact x is some closer to a, that is a dash, and y is b dash, some closer to b. I am writing here a dash is closer to a, b is closer to b. So the resulting z is also closer to c. You can write this C is equal to A given composite A cross C union composite intersection B maximum composition B cross C. So these are the modus ponens. Now check modus tollens. So now generalized modus tollens. So here fact is that OI is B dash. Rule is that if X is A, then Y is B. So here conclusion is that X is A dash, where A dash is closer to A and with the same degree B dash is closer to B. Just like these things, you can write that Y is B, then X is A, then X is A. So here you can write it fact, here you can write conclusion. So here you can write fact, here you can write conclusion. Y is B, X is A. Y is not very B. Y is not very B. X is not very A. So these are the fuzzy expression. If Y is not more or less B, conclusion is X is same degree, not more or less A. So these things are the modus tollens. Now try to understand the next concept, which is that generalized hypothetical solution. So here fact is that there will be two rules. So rule 1, if X is A, then Y is B. Rule 2 is that if Y is B dash, then Z is C. Conclusion is that if X is A, then Z is C dash. So B dash is closer to B. Here B dash is closer to B. The same closer C dash is closer to C. So this is known as the hypothetical solution. Now try to understand some example of generalized modus ponens. So this is the rule: if X is A, then Y is B. So here we can find rule which is A cross B, or you can find union A complement cross Y, where this every membership value of this Y is 1. So fact is that X is some value of A dash. So this A dash is closer to A. So you need to find the output. So question is that consider is A. So which is that A is x1 0.5, x2 1, x3 0.6, Y membership is y1 1, y2 0.5. The given A is A dash, which is x1 0.6, x2 0.9, x3 0.7. We need to find the output, that is y is, then y is b dash. So here is the value, that b dash is equal to max mean composition of given a of Rxy, where Rxy can be written as that, though, so that is the max mean definitions. So now A cross B, so find the minimum value. So input is x1, in the row you will find x1, x2 in the row. So now try to find A cross B. So in the row you will find x1, x2, x3. In the column you will find y1, y2. Take the minimum value. So 0.51, 0.5, 0.4, that is 1, that is 0.4, that is 0.6, that is 0.4. So we find this part A cross B. Now find A complement. So here A complement will be these things: x1 0.5, x2 0, x3 0.4, and y everything will be 1. So y everything will be 1, that is y1 1, y2 1. So now try to find A cross y. So that is x1 0.5, 0.5, x2 is 0, x3 0.4. So now you take rxy, which is the maximum of these two. So 0.5, 0.5, 1, 0.4, 0.6, 0.4. So now B dash is the composition of A, which is given 0.6, 0.9, 0.7, max mean composition of this 0.5, 1, 0.6, 0.5, 0.4, 0.1. So 0.6 and 0.5. First to find the minimum value. So that is minimum of 0.5, 0.6 and minimum of 0.5, minimum of 0.9 and 1, minimum of 0.7 and 0.6. So you will need to get the minimum first, so that is 0.5, 0.9, 0.7. So maximum is 0.9. So here that is 0.9. Similarly, if you compare with that, you will get it minimum value is 0.5, 0.4, 0.4. So maximum 0.5. So that is the output value. So that is the fuzzy output, y1 0.9 and y2 0.5. So hope you have understood the generalized modus ponens with examples. So similarly here there is some questions. So here there are some questions you try to find. So here given age 71, 81, 90 0.3, age is 30 0.8, 40 1.0, 50 0.6. The given ht is that 90 0.9, 101. Find this r h cross s union h complement y and the value of q. Here rule is that if x is h, then y is s. So fact is that x is ht, some said x is xt. Now find the value of y. So that is y is something like q. So try to solve these questions. Here another question is that there is three fuzzy set. So another question is that there are two fuzzy set, tall x and old x. So these are the output of hx. The height is 150 centimeter. Then it is not at all, so 0. If it is 100 to 200, then hx minus 150 by 50. If hx is 200 more than that, then it is surely 12%, so it is 1. Old x is something age. If it is less than 18, it's not a old age. 18 to 60, so that is the membership function, and greater than 60, so that is 1. So and rules are that if x is tall and x is old. B rule is that if x is tall or y is old, C is that not x is tall. So there are some input 135, 173, 155, 192, and for the old age inputs are 80, uh, 10, 85, 40, 22. Try to find the value of these things. So as for example, if I write 135, so 135 belongs to here, so that is 0. Then if I write it x, that is 10, 10 also 0, so and you take 0, so like that you will get the input and output. So for all these values, try to find the value of this a, b, c. Okay. In this class we have learned generalize, right? We have learned generalize, modus ponens, generalized, modus tollens, and generalized hypothetical solution. So the question is that with proper example, try to understand these rules. So these are the references for today's class. Thank you. Have a nice day.